Afternoon, everyone. Today, let's look at the AD7224 digital to analog converter in bipolar mode. Now, I've got a video of testing the same IC in unipolar mode. And I highly recommend that you go back and take a look at that video because I go into great detail on these digital inputs right here. I don't want to use up your time telling you all about these digital inputs again when you can go back and look at that video and learn about these digital inputs. So let's talk about bipolar output operation. The difference between unipolar and bipolar use of this IC is that on the output of the D-to-A converter, we run it into this op amp right here. Now what this op amp does right here, it allows for the digital inputs a swing of plus and minus VREF. This is your VREF input right here. Whatever you have, whatever voltage you have on this VREF pin will be the peak output, plus or minus. We're going to set it up for plus and minus 10 volt operation in the test. So for the digital input, will swing anywhere between plus 10 volts and minus 10 volts. Let's go down here and we'll look at a chart that shows that data. So here are your digital inputs, and these are your analog outputs. For a digital input of 1000, 0000, we'll have 0 volts on the output of that op amp. For a digital input of 1111, 1111, we'll have very close to our 10 volts. This is plus VREF times 127 over 128. Our VREF is 10 volts. So we'd be very close to 10 volts. Now for a digital input of 0000, 0000, we'll have our VREF, it'll be negative this time, divided by 128 over 128, or 1. So our VREF, when we have all zeros on the digital input, should be very, very close to negative 10 volts. Now let's look at the power supplies and op amp circuitry that makes unipolar mode and bipolar mode different. Now this circuit right here is the power supply circuit for unipolar mode. We only have plus 15 coming in. That goes up here to VDD, pin 18 on the D-to-A converter. We have a 1K resistor here and a 10 volt Zener that make the 10 volts for the VREF input on pin 3. You'll notice here that VSS is tied to analog ground and digital ground. And for the logic inputs, we need 5 volts logic input on these guys. So I run that through a 7805 voltage regulator that takes our 15 down to 5 volts for the logic. Okay, Now we're going to look at the schematic of the power supplies and op amp for bipolar mode of operation. Here are the connections of the power supplies, operational amplifier to the AD7224 in bipolar mode. We have plus 15 volts DC, ground, and negative 15 volts DC. The plus 15 volts DC connects to pin 18 VDD of the AD7224 digital to analog converter. It also comes over here to pin 7 V plus of the operational amplifier, and we're using an OP07 DP. Negative 15 volts DC comes down here and connects to pin 1 VSS. Now in unipolar mode, VSS was also connected to pin 4 analog ground and pin 5 digital ground. But in this case, it's connected back to negative 15 volts DC power supply. That negative 15 volts DC also comes over here to pin 4 of the operational amplifier, the V minus input. The V plus and the V minus are the supplies for that operational amplifier. Now, the digital logic requires plus 5 volts DC for this AD7224. We derive that from this 7805 3-terminal voltage regulator. It's a 5-volt regulator. We take the plus 15 volts into pin 1, and the 7805 drops it down and regulates it to plus 5 volt DC. The VREF input is generated from this 1K ohm resistor and this 10 volt Zener diode. We take this plus 15 volts DC down to the 1K, and the 1K and Zener diode make the 10 volt reference, the 10 volts DC for the V reference input on pin 3. The Zener diode's anode is connected back here to power supply ground. On the operational amplifier, pin 2, the inverting input of that operational amplifier, is connected to VREF, that 10 volt Zener, through a 10 kilo ohm 1% resistor. It's quarter watt at 1%. The feedback loop of that operational amplifier, pin 6, the output of the operational amplifier, is fed back to pin 2 through this 10K ohm 1% quarter watt resistor right here. Now the output of the digital to analog converter is on pin 2, and that is connected to pin 3, the non-inverting input of that operational amplifier. And we're going to look at pin 6, the output of the operational amplifier, reference to ground, with either a voltmeter or an oscilloscope. And in our case, we're going to look at it with a voltmeter. This is the setup for bipolar mode of operation of the AD7224 KN digital to analog converter. Now here we have the DAC set up so that it will feed the input of this OP07, and its output will swing from -10 up to 0 volts and out to plus 10 volts. So we have a swing of plus and minus 10 volts. Now, with the 8 data bits set to 1 0 0 0 0 0 0 0, that's decimal 128, we have pretty close to 0 volts on the output of the OP07. It's 145 millivolts. Let me close this bit 0. We have 212 millivolts. Let me close bit 1. There's 0.358 volts, or 358 millivolts on the output of the OP07. Here's bit 2. We have 0.658 volts on the output of the OP07 operational amplifier. Here's bit 3. We have 1.267 volts. Bit 4, we have 2.495 volts. Bit 5, we have 4.96 volts. Bit 6, we have 9.91 volts on the output of the OP07 operational amplifier. Now I'm going to flip bit 7 to 0 volts. And now our data bits are 0, 1, 1, 1, 1, 1, 1, 1. Let's see what happens. And we have 7 millivolts on the output. Let's see what happens when I flip bit 0. Look at this. We're starting to go negative. There's negative 62 millivolts. Let's flip bit 1. So that now we have 0, 1, 1, 1, 1, 1, 0, 0. We have negative 0.209 volts. Flip bit 2. We have negative 0.510 volts on the output of the OP07 operational amplifier. Flip bit 3 low. We have negative 1.119 volts. Let's flip bit 4 low. We have negative 2.345 volts. Let's go low with bit 5. We have negative 4.80 volts. And now bit 6 low. We have negative 9.73 volts. That's all 8 data bits low. Let's set them all high. There's all 8 data bits high. You have 9.90 volts DC on the output of that operational amplifier. So when all 8 data bits are high, we've reached the max of 9.91 volts. When all 8 data bits are low, we reach the max of negative 9.73 volts in the other direction. We set bit 7 so that it's high, and we're at basically 0 volts. It's 141 millivolts right there. Isn't that amazing? That is amazing. Thank you very much for watching. That was a lot of fun. I hope you enjoyed that.